The next presenter is Dr. Liang.
Oh, excellent.
I'm sure it's 5 minutes and 2 minutes.
Hello, everyone. My name is Liang. It's the same as my first name and my given name. Very convenient. And, I'm a research assistant from Edge Hill University. I recently joined the university as a research assistant. My job is normally behind the research project, just collect data, analyze the data, and being quiet. My research project is about from products to services through Internet of Things. I'm looking at a case of a back-sharing product service system. My background is, you can say, half of me is made of like a business degree. I'd say the other half is made of computer engineering. And my research interests are first PPS, second is Internet of Things, the last thing is about big data. Just give a little bit of background about what back sharing is. The back sharing basically about the products are the bags you see here, and also a back storage stock. And the service provided by electronic devices, so people can self-service themselves, check in, check out. And then put the people and the technology together, and the bags, that's back sharing system. The reason this thing is good now and popular because it's part of the green economy as an alternative transport for big cities and small cities. My research question is looking at the processes, how we turn products into services through Internet of Things. And I did a little bit literature review to say what are they. So basically literature tell me, okay, first of all, back sharing is a PSS, and the second thing is IoT. I said, okay, that's things I already knew. And also look at what information are sharing between stakeholders in the system. So basically, that's my first research finding, looking at the whole processes, how people develop Internet of Things in back sharing system. This starts from planning stage to development stage, and also involve design stage in between at the end, how they deliver with the projects. And the stuff from here is, you see, all the events, the tasks, as a sequence, one after the other. And that's how we map the process, so we can repeat project again and again. But what I'm more interested in is how people interact with each other in this kind of processes. So I started to look at who are involved in here. So we say, okay, different organizations, people from different organizations are involved in this quite complicated system. Then I dropped into a deeper level, say, okay, the theory says in this kind of what we call is network connected, you need open network like that, and also closed network like this. Some people, if you're familiar with innovation theories, some literature refers to structural holes. This is related to interconnected relations. So structural holes, the open network can create some new innovations, a very creative structure for people working together. And the closed network is much more efficient, involve more teamwork. That's why people are fully connected. So the method I use first is a network modeling how people work together as in a project-based IoT development, and then using regression modeling test that network against the performance. So basically I'm working on 4 projects at the moment, one from London, one from Liverpool, one from Prague, the last one from Paris. That's the, you see the nodes here are people, and the connection between them are the teamwork and information exchange between them. I just take one as example. This is the one in London. There's 43 people working together. You see the engineers, the service designers, and the management team. Basically, this data collect during was 10 weeks time. From very beginning, you see the first week, there's nothing happened until until 9 weeks time, the network being stable, nothing change anymore. So we start to analyze this network. We say, okay, right in the middle of this network, there are people, what we call them brokers, transfer information from one side about the service design to the computer engineers. There are 5 types of brokers here. You say, just take 2 of them as example. One is called representative. It's a person represents the service design group to tell the engineers what to do. And the other one is a gatekeeper. For example, when we want to approach a group of computer engineers, that's the most efficient person who can go through to pass information to the whole group. And also I found the second thing is the interlocked relationships in the network are very useful because that represents more teamwork, more efficiency. More this kind of triangle structure in the network, the more likely the project will be done more quickly. So to prove that, I ran a regression modeling to see how the R squared changed from 0.44 to 0.667. And I was a little bit OCD, so I tested it against another dependent variable using the individual performance as dependent variable. Again, it works. So that's how I concluded the project. Say, okay, so when we have everything we knew before about what can influence IoT development, that's all the control variables there, we can probably explain the outcome about 50%. And when we add innovation broker in there and the network structure in there, we can explain about 71%, so we get a better model after that. So in terms of publication, my previous research was working on the information technology in tourism sector, and currently moved to the IoT area. And this year, as you see, the finding I presented, we are going to break it down into 3 papers to be published in this year. In terms of research funding, I had a research grant from China Academy of Management Science before, and currently my research project is funded by the university. In terms of collaboration, since I worked with the tourism industry, so I had some contacts with them. And at the moment, we work with a bag sharing company, which is called Our Bag. Thank you very much.